Alright class, today we're doing inverse trig functions and composites that might not be those nice unit circle angles. I'm going to try doing something a little different than I did in class to help clarify things. Things you need to remember. When you take sine inverse of something or tangent inverse of something, you get an angle only in quadrant 1 and 4. Cosine inverse is only in quadrant 1 and 2. So that's kind of important to remember when we keep going through this. Also remember that reference angles are the closest angles to the x-axis. So you're measuring to either 0, pi, or 2 pi. And remember your quadrants, all students take calculus. So here's what I'm going to do. You can pause the screen if you need to write all this down. And then unpause and keep going. If we look at this, we see that we have the sine of at negative pi over 8. So if I draw that, this is where I'm doing something different. Negative pi over 8 is right here, so I'm going to put a dot. I'm going to draw a triangle where we have x and negative y, because I'm just telling you the signs of these distances. Well, so now I want to know sine inverse. I want to know the angle this is at. Well, you have to double check. Sine inverse should give me something in quadrant 4. This angle is in Q4 already, so I don't have to do any work. These in essence cancel out for this problem only, and I can just say my answer is negative pi over 8. That's the angle that this trig function is at, because that trig function I evaluated it at that angle. Okay, so you want to see what quadrant you're in first. So when I go with negative 3 pi over 7, remember this is 1/2, so this is less than 1/2, so it's about down here. Again, x is positive, y is negative. But again, tangent inverse, then we want the angle in quadrant 4 or 1. Well, we have it already in quadrant 4. The angle is negative 3 pi over 7. So those are the two very simple ones, because we already have the correct quadrant when we're doing this problem and canceling those out. Now let's get to another problem where we get to this one here, sine inverse of sine of 17 pi over 12. First thing you have to figure out is, where is this? Well, 17/12, remember this is like 12 over 12. So that means I have 5/12 left. So it's something like right here, where this reference is 5 pi over 12. That's this angle right here, the R reference. It tells me that my x is negative and my y is negative. Okay, but all I care about for this one is sine. So sine is usually the y value. So that means I need to find the quadrant where the y value is negative, but that's not this one, because I can't get an answer in quadrant 3. I need to either be in 1 or 4. Well, just by drawing the triangle, you guys should all know that it'll be in quadrant 4. There's my other negative y. I don't care about x for this one because I'm talking about sine. So I want this angle here. Well, the reference angle should match, so this angle is 5 pi over 12. And then the last step is measure to that angle. Well, to go this way, the answer would be negative 5 pi over 12. Let's look at a cosine. Negative pi over 7 somewhere here. So x is positive, y is negative. Again, cosine inverse, you have to be in either quadrant 1 or 2. I need to be in quadrant 1 or quadrant 2. I'm in quadrant 4 right now. So where's the other place where cosine is the same? Well, x is positive here, so cosine is also positive up in quadrant 1. So if my reference is pi over 7, this angle here has a reference of pi over 7 as well, and it has a positive x. So I want to be in quadrant 1 instead of 4. And if this is my reference, I'm moving in a positive angle direction, so my answer would just be pi over 7. Let's keep going. Now I'm drawing an angle 7 pi over 5. Okay, well this is again 5/5 because it's over here. So we're going to go 2/5 more. So that's about here. I'm just going to make up something. Again, my x is negative, my y is negative. The reference is 2 pi over 5, because again we used 5 to get to pi, and so we have 2/5 left. I have cosine now. Again, I need to be in quadrant 1 or 2 for cosine. Well, cosine is x, so I already have negative x. I need to find the other quadrant where x is negative. Well, the only thing that makes sense is to draw the triangle here with the same reference. Okay, I'm going to move this x here. So here's a reference angle of 2 pi over 5. This is probably the hardest one to come up with the angle, because the answer is not 2 pi over 5. The answer is you need to get... Uh-oh, my OneNote's not responding. There it goes. You need to get to this angle this way. So if this whole thing is 5, and this reference is 2/5, this angle then must be 3 pi over 5. And that is the correct answer to that problem. So that's probably the trickiest one. So again, you're looking at which one you want. If it's cosine, you want negative x, if it's or positive x, depending on which way the original angle was giving you. Sine, same thing, you're looking at the y's. Tangent, you're looking at x over y. So let's look at a tangent right now. So again, this is 13/13, that's 1. So I have a reference of 2 more 13ths right there. I have negative x, negative y. But tangent here, remember tangent is the y over the x. So that means it's positive. So you need to find the other place tangent's positive. It's either in quadrant 1 or 4. And since everything is positive in quadrant 1, it's over here because now this is a positive x, positive y. If I divide those, I'll get a positive. We found that the reference angle was 2 pi over 13. And that also happens to be the answer to the problem, because now if I measure from here to here, that is that angle. Alright, so that's how you do those. You also have to remember a couple other things. Remember that sine and cosine only have values between -1 and 1. Where tangent can have values, I don't know how to spell today, between -infinity and infinity. So now we're going to do two problems where we're kind of reversing the process. I want to know what the trig function is at the angle where the trig function is 3. So I'm going to do it with triangles here, even though it's basically just cancels out. It's saying that I have a triangle in quadrant 1, because it's positive, 3 over 1, where the y is 3 and the x is 1. So I drew the angle. It's right there, whatever this angle is. So now it's saying, what is the tangent of this triangle? Well, if you look at it, it's the same thing, right? Tangent is opposite over adjacent. So these, in essence, cancel, and you're left with just 3. This is where the problem comes in. This is saying cosine inverse of 3 over 1. Cosine can't be 3. There's no triangle that exists, and I'll show you why. If we draw it, I draw a triangle. It's saying that the adjacent side is 3 and the hypotenuse is 1. That can't happen. You can't have a triangle where the hypotenuse is less than one of its sides. So this is undefined. So it's either going to be undefined if it's higher than 1, or it's just going to be the value that's given if it's the same trig value. Okay? Alright, that is it for today.